Hello, ladies and gentlemen, and when we last left off, we were talking about metamorphic rocks and how they form either due to regional metamorphism, where we have pressure from plate tectonics pushing on the rock, or from contact metamorphism, where magma or lava is contacting the local rock of that region, and how it causes a recrystallization of the minerals that make up that local rock. So now we're going to look at characteristics of metamorphic rocks. One of the easiest characteristics of metamorphic rocks to identify is distortion. Distortion is when the minerals in the rock become twisted or distorted. So here you can see these alternating light and dark bands that run through. But notice they're like in these weird patterns that follow through. This is because there was stress put on the rock and it caused it to crumple. And when it did that, the layers right here got distorted. We can see this in rocks here. So these were the little veins coming through, and notice that they all follow the same pattern, more or less degree. And when they do that, that right here, or even on this section right here, those patterns are representative of actual forces causing those bands to kind of rearrange or change direction. Looking at a little bit closer, you can see the coin there just to represent the size. But once again, you can see the same pattern follows through. And then if we look at this little vein right here, notice that goes to the same thing. So a little pattern formed through the same thing, just that metamorphism, that regional metamorphism, changing the recrystallization of those minerals into these patterns. Quartz and quartz schist, we can see them there. Quartz coming through. Okay, we can also get garnet crystals. We get a recrystallization, which allows any garnet that was in here to kind of come together, to coalesce and form these larger crystals. We also see foliation or banding. Here, there's a recrystallization of the minerals into light and dark bands. Notice here they're a little bit more even. Not perfect, but definitely we have a light, followed by dark, another light, then dark. So the foliation and banding is very easy to see, along with distortion. They're along the same lines. We're just looking at a different grade of regional metamorphism that's forming them. And if we look now at our reference table, remember, we first looked at the type of metamorphism, but notice this regional metamorphism is almost always associated with some sort of foliation, which is the top half of these rocks. So slate, phyllite, schist, and gneiss all exhibit some sort of foliation, whether it's mineral alignment or it's banding, like we just saw with those light and dark patterns. Versus the bottom half of this chart, which are non-foliated. So these can either be formed regionally or through contact metamorphism. Here's our foliation once again. So here's our minerals. Notice that there's no real arrangement, but if we apply pressure to it, we can get them to start lining up. Depending on how much pressure we have, we can get these to really separate into light and dark bands or form bands of minerals. Here's non-foliated versus foliated. So there's definitely a clear difference between the two types of rocks. And continue on. Notice this is like a sample of granite right here. No real orientation of the minerals. Apply a stress to it, and we get our bands that are up here, or our light and dark regions, which shows those minerals lining up. Here's some more foliation. See, there's some lighter minerals here, darker, lighter minerals. So they kind of group or kind of coalesce together. Here's marble, non-foliated. It's pretty much the same all the way throughout. Remember, this was sandstone, mostly of quartz sediments or sands, and then they compact together, form sedimentary rock, and if we push, apply some heat to it, we can get those sand particles to actually recrystallize and form into these larger crystals that we would see here. We also notice with metamorphic rock, there's an increase in density. Here, we got this woman pushing on this rock. It takes a little bit more effort than what she has, But because we're pushing all this stuff in and closer together, these rocks become more dense and usually are more resistant to weathering because of that. And here's our compressive stress, and notice how it's going to stretch out some of these particles that are in there. When we're pushing so hard, all this stress is mounting on these rocks, or so much heat is applied to them that it actually changes them a little bit, it would cause anything that would be in them, such as fossils, to basically be destroyed. So we don't normally see fossils in any sort of metamorphic rock. So if you see a fossil, most likely it's that metamorphic, which would identify it as a sedimentary type rock. And it goes the same for igneous. There's that molten material which would destroy any fossils also. So metamorphic rocks, we're not going to see fossils. Igneous, no fossils. Sedimentary, we will see, or we can see fossils in them. That's it. And the metamorphic rocks, nice and easy. Now at this point, we've seen all three types of rocks, igneous, sedimentary, metamorphic, and you should be able to, at this point, identify them without a problem. Hope you enjoyed this screencast. Take care. Goodbye.